After receiving his business degree, John is offered positions with two companies. Company A offers him $80,000 a year with a $1,000 increase each year. Sounds good to me. Company B offers him $60,000 a year with a 4% increase every year. Now, it sounds like he should go with Company A, and that is true, but it's only true up to a point. Exponential growth overtakes linear every time. It might take a while, but it'll always overtake it. So, after how many years will the Company B salary be higher than the Company A salary? Well, let's compare these two. We're going to have Company A, and we're going to have Company B right there. Slide this over. It's shaking a little bit. There we go. And we're going to write some functions that will help us really interpret this. So Company A is going to have an amount that starts at $80,000. This one's going to be linear, and we're going to have a $1,000 increase for every year. So year 0, it's $80,000. Year 1, after one full year, it's $80,000 plus 1, so $81,000. You get the drift. Well, Company B is going to start at $60,000. And this is one of these situations where we pull out an old trusty formula. We're going to do that because that's a percentage. So we're going to start at 60,000 and we're going to go 1 plus, and then it's 4%, so 0.04. And then we're going to raise it to the T. All right, so now the question is, after how many years will the Company B salary be higher? Well, clearly Company A is higher at the beginning. Company B is not. So let's figure this out. Let's do it a little bit differently. We could do it all kinds of ways. We could do it graphically. I'm going to use a table. I'm going to use a calculator for this, actually. So I'm going to press Y equals, and you can follow along on a calculator, or you can type it into Desmos if you like. And you can follow along with something similar. We'll get to the specifics of that in a minute. But 80,000 plus 1,000x, I used T, but that's okay. And that's Company A. Here's Company B, 60,000. And then 1 plus 0.04, so 1.04. And we're going to raise that to the x value, to the x variable. And so if you are using Desmos, you will, in a blank little section, you'll type the word table. And you'll be able to pull up, oh goodness, you have to define this one as like f of x equals, and this would be like g of x equals, and then you type the word table, and then you're going to get like x sub 1. Now it's getting confusing without seeing it. Anyway, and in the columns you can put f of x sub 1 and g of x sub 1. Anyway, and it'll crank out the values. I'm going to just go to the table and type in whatever I want. So at year 0, we're sitting at 80,000 and 60,000. At year 1, we're sitting at 81,000 and 62,400. At year 2, we're sitting at 82,000 and 64,896. Okay, both increasing, but increasing at different rates. This is increasing at a constant rate. This one is not. 4, 5, 6, 7, 8. All right, so John, if he's going to be short term with any company, he should be with Company A. But long term, he should be with Company B. But after what time? Like, he needs to look ahead. Now they're really gaining on each other. Here's 9, and here's 10, and they're about the same. So then when I get to 11, which I will type up here at the top, at 11, Company B has overtaken Company A. So used a table here. If you use Desmos, that was a really terrible explanation earlier, but I'm going to do just a super fast sketch of what that is, and you're going to see the actual graph of it. So the original graph for Company A is, well, linear. Here, let's just do it this way. I know it happens between year 10 and year 11, so I'm going to graph this on a window from 0 to 11, and let's just do a zoom fit. It's going to take it a second. Okay, here's Company A. Whoops. And Company B looks linear, but it is not. It actually starts way down here because the Y values, the Y minimum for me is 60,000. Just saying. So it's actually going to be like one of these situations. I shouldn't have drawn the negative end on that there because he doesn't work for the company for a negative amount of time. But this little curve that shows up, you're going to have a point right there, and that point Specifically, if you want to get really technical about it, I have found it on Desmos. I can find it here. I will do that with a point of intersection. And it is going to be at 10.471 years. Yep, double checking, making sure we're good. Yep, that was it. 10.471 years. Okay, after how many years will the company B salary be higher than the company A salary? 10.471. Well, this happens actually every year. So after 11 years, we'll round that up, B has a higher salary than A. Again, exponential growth beats linear every time. Might take it a while, but it'll get there. Biologists are studying a new bacterium, and they create a culture with 400 of the bacteria and expect that the number of bacteria will triple every 48 hours. Write an equation for the number of bacteria in terms of the number of hours, T, since the experiment began. This one's pretty straightforward. It's actually going to be a lot like the isotope, yttrium. So we are dealing with something that triples. So that is a growth factor. And we are dealing with number of hours in terms of T. So X is not X anymore, it is now T. And let's see, the equation for the number of bacteria, B equals a little b to the T. Okay, so we're going to figure this out. Now, we create a culture with 400 of the bacteria and expect that the biologists, and expect that the number of bacteria will triple every 48 hours. So that means over here on the side, we started with 400 and it's going to triple every 48 hours. That does not mean T is equal to 48. What it does mean is if we only have 1 hour, then we've not passed the threshold of one entire time period. The exponent in this case doesn't just represent time, it represents number of time periods, so we have to divide it by 48 to make it work. This is the same kind of situation, again, we had here with the 64. If I wanted one full time period, then it would be 48 out of 48. That would be an exponent of 1. So my final answer here is the number of bacteria that I'm going to have is equal to 400 times 3, and I'm going to raise it to the number of hours divided by 48.